Hey everyone, I hope you are all doing well. I'm just gonna get some video enabled here. Hopefully we're all good. Awesome. All right. Good to see everybody. Thank you all for joining. We're gonna open a couple more tools here as we wait for people to jump in. So, for those of you who are new to this, thank you for joining. My name is David Awad. Joined with me in the chat is one of my colleagues, Peter Lee. The two of us are developer evangelists here at R3, working on Corda and newly Conclave. We're going to talk to you guys today just a little bit about how the Corda token SDK works and try to give you some clarity on how you can use it in your CorDapps. So if that sounds interesting, by all means, stick around. If you have any questions whatsoever, please don't hesitate to post either in the Q&A or in the chat. As long as your stuff is publicly visible, Peter should be able to get to it, and he'll be able to answer any questions you guys have as you go. So hopefully all that sounds good, and we will not have any issues. All right. So all that being said, I think we are good to get started. So like I said, this is the Corda Token SDK workshop. And so what we're going to be talking about primarily is the Corda Token SDK. We're assuming you have a little bit of knowledge going into this. If not, it's no big deal. So we will just get started with a quick recap on the components of a CorDapp. So every CorDapp comes with a couple of things that are relatively intuitive, right? You as an individual run a Corda node, with the goal being to interact with other individuals running their Corda nodes. And so CorDapps outline the interactions that are possible for you to have between the Corda nodes that represent each of you. And so there are some things that you would want to have, the first being the objects themselves. You want to be able to represent unique and specific objects in your program code. Those objects are states. States are your objects in Corda. States are created on the ledger, they are consumed, and they are updated. Then you have contracts. Contracts are the code you can define to verify the transactions. If you can think of transactions as interactions between your Corda node and other Corda nodes, then you can define contract rules based on the type of transaction. So for example, if I'm selling a car to Peter, then we both have Corda nodes, and one of the transactions that might be possible in the car contract would be enabled by a command that says, let's say, to sell. A contract command to sell a car from me to Peter has to have a couple of rules. Let's say if I'm in New Jersey, a valid car is going to have 6 characters in its license plate. Maybe I don't want to sell my car unless it has over 50,000 miles. And then the last piece of this is going to be flows, right? If I'm going to sell my car to Peter and we're going to adjust the Corda ledger to reflect this change, then we need to understand a basic framework of how the big picture flow of business logic really kind of works. And so real quick, there's node A, node B, and a notary pool in the most simple or the ideal transaction. That would be where my node, node A, proposes an update to Peter's node where I say, I'm going to sell you my car. And so my node proposes the update. It checks the update, meaning I perform the contract verification on the transaction I am proposing, making sure it is valid, and then I sign it with my node, and then that transaction is broadcast out to node B, which has the same set of CorDapps installed. Because of that, when node B receives this information, it checks, Peter's node checks using the same contract code, the same CorDapp code that we wrote together, and then it checks and signs the update. Then it sends that approval back to my node. Once my node is aware that all of the required participants, both me and Peter, the parties to the sale, have signed, then we can inform the notary pool, which will sign the update, and then inform my node again, because I'm the one initiating this flow, that the notaries have validated it, or notary has validated it, and that's all configurable, but a little bit outside of our scope here. My node will record the update and then inform Peter's node, which will record the update, at which point we have all of the required signers have approved of the transaction. It will be added onto the blockchain, or the ledger, if you will, and we will be all set. So take a minute to process that. I just gave you a lot of information. But if all of that makes sense, then you should be all good with that, and we'll be able to follow along as we jump into the tokens SDK and how that works. So without further ado, what is a token? Right? We have a good picture here, or a good place to start would be to think about a coat check. Right? A token is a representation of an asset. So when you take a coat check tag, you'll notice that there's two different pieces of this. I, funny enough, worked in a coat check at a catering hall as my first job when I was in high school. So I know this quite well, right? You take a coat check, these tags are prepared ahead of time by the business, and you are given the bottom half. You're given this claim check so that you keep that in your pocket, and they take the other side of it and they put this on the coat hanger where your coat is. So this 605 is a symbol, a symbolic link to a physical object, you could maybe say. So this is a representation of your coat. If this is lost, then you cannot reclaim your coat until everyone else has reclaimed theirs. Another good example you could think of is maybe a cryptocurrency. It's a little bit digital, or sorry, it's a little bit different because it is entirely digital. And so it's worth being aware of how the different kinds of assets can be represented when you do things like this. So where can we take this idea? Well, if we have physical and digital tokens, a fairly large amount of people might think cryptocurrency, but digital tokens also include tokenized assets. So when you buy a stock, as a great example, I'm not going to go, let's say I bought a share of Palantir. I opened up Robinhood and I bought a share of Palantir. I'm not going to go call Palantir. I'm not going to call Peter Thiel and say, hey, I would like a copy of my paper stock certificate, because he would probably laugh at me. Because you don't always need the physical representation of an asset. Sometimes the digital representation is enough. Any of you who have traded public markets with options contracts probably know what I mean when I say that you don't need to have a physical representation of every asset. So while today is not exactly going to be a rough primer on all of the different kinds of tokens that can exist, we'll do our best to kind of give you a really solid understanding. And so remember that digital tokens can be things like a deed, or a fractional ownership of a house, or of a stock. You can do that too. Maybe if you've used Robinhood, you've noticed you can buy things like fractional shares, and you can do things like drip investing, where dividends are reinvested into smaller shares of the stock, and you get a percentage of the dividend. So without me rambling further, what is a token on Corda? It's not a cryptocurrency, but it is a digital representation of asset ownership. So for example, a bearer instrument that would represent a liability between an issuer and an owner, where an issuer is the person issuing to me a representation of my ownership of a stock that person has sold me. So if I buy a stock through a digital exchange or something like that, what I would get in response is actually a digital record of my ownership, not necessarily even the stock itself. And I may never see the stock. I could trade entirely based on the digital ownership or the bearer instrument. So imagining this, or extrapolating this example a little further, you can think about what a tokenized economy on Corda could look like, where you have peer-to-peer transactions over a decentralized network that provide you the highest security. And in addition, you get traceability, because you can, as a user and a participant in a transaction, you can retrieve a pretty credible history of any ledger asset. You can also configure your notaries to do this for you when any transaction happens. So whenever there is an asset that exists that you're in a transaction you're involved in, you can take this asset and trace back its entire history from its original issuance on the blockchain or the Corda network that you're participating on. And of course, you get increased liquidity and market access because if you can represent and trade digital or fractional digital items or tokens over markets, you enable new sets of owners. Like I was talking about earlier, there are entire classes of investors that now can get access to fractional shares if they don't have the money for, say, a share of Berkshire Hathaway, which is currently something like $300,000. You can buy, let's say, 1/100th of a share of Berkshire Hathaway or something like that. So illiquid assets can now be represented and traded fractionally, which can be quite nice. So let's get under the hood for a minute. We're going to talk a little bit more specifically about the Token SDK. We'll talk about fixed and evolvable tokens, what those are and how they are represented. Then we'll talk about fungible and non-fungible tokens, and we'll talk a little bit more about token management. So the Corda Token SDK provides a standard library to you to create and manage your tokens in Corda. So unsurprisingly, there are a series of commands that you get access to. The ability to create, the ability to issue, move, and redeem. And these mean pretty intuitive things, but there are some subtle differences, so just bear with me here. The create command creates an underlying token type for the token. This can be fixed or evolvable. Issuing the token issues the tokens to the designated holders. Moving the tokens moves them around the network. Again, you're moving the token, not the underlying asset. And redeeming destroys the token representation and claims the asset itself. So for example, if the exchange has one share of a stock owned by the exchange, but I have purchased a token representing the share, I can take the token and sell the token to somebody else, and they can redeem it if they wanted to. They can redeem the token for the actual stock in order to have that stock be owned by them and not the exchange within this theoretical Corda network. Or maybe a better example to say an options contract might be an easier way to think about the idea of the contract resolves and it completes based on a certain day at a certain strike price. And so when the options contract is exercised, the contract itself disappears and the shares themselves are traded. And so it's important to remember that at the end of the day, the Token SDK comes in the form of simple jar files. These just have to be copied onto your Corda node. They just have to be copied into your CorDapps in order for you to be able to use them. There's nothing particularly difficult happening here when it comes to installation. It's pretty much a couple of lines inside of a Gradle file, and you'll have no issues getting your CorDapps to compile and getting your tokens to work. So I mentioned earlier fixed tokens and evolvable tokens. So what is the difference between these two things? A fixed token is something like a currency, right? Something that is relatively fixed. $1 is going to stay $1, as opposed to something like an evolvable token, which is a house or a car or a contract between two people, something like that. So let's look at how you might implement these. There's a bit of a token type hierarchy to really bring this home. So with a fixed token, we really just create a token type object. The attributes of the token type are fixed, and you really can't change any of them after, which makes sense. So with evolvable token type, it gets a little bit trickier. You need to create a separate Corda state to store all of the evolvable attributes. In the example we're going to talk about in a little bit, we'll see how to create a Corda state called a house state, which is an evolvable token type state. And it has some evolvable attributes too. So speaking of Corda states, if you want to chase down the path to see actually how evolvable token types are implemented, you'll actually see that underneath it, it's a variation of linear states, which of course are just contract states. And you don't really have to worry about what's going on within the core of Corda. You just have to focus on the specific abstract classes you're working with. And so that's really just going to be evolvable token type and token type. So let's jump into the editor real quick and I'll show you what I'm talking about. Hopefully you can find this pretty easily online, and I'll paste a link into the chat on how you can do this in a little bit. But just bear in mind that inside of our samples-java or samples-kotlin, inside of the tokens folder, I'm looking at the $house token CorDapp. And if you go inside of there into workflows, source, main, etc., you'll find house token create and issue flow, which we're going to look at in a little bit. And inside of contract, source, main, Java, states, house state.java, that's where we are right now. That's where you will find examples of some of the code we're going to be looking at. We're going to only be looking at the $house token CorDapp. So hopefully you don't have any trouble taking a look at these code examples on your own. So inside of here, you'll notice we've implemented a state called house state. It extends evolvable token type. It does not extend the contract class that you would. So be aware of that subtle difference. But all an evolvable token type is just a Corda state, like we talked about. Now, here are the fixed token types. They're just called normal token types as far as we're concerned. And they just represent types which can be embedded inside of a non-fungible token or fungible token state, right? So all token types have a token identifier. They have an int, that is their fractional digits. They have their display size and a couple of other little things, whether they're a custom token type, and they maintain their pointer. They have a hash code and a string representation, and that's pretty much it. That's all that goes into fixed token types. Evolvable token types get a little bit more complicated. Within evolvable token types, they store token reference data that we expect to change over time. Reasonable enough. They're state objects because the expectation is that they evolve. Inlining a linear state, like we described earlier, makes sense. And so inside of here, we get a couple other things, but really all we're worried about, again, is just the ability to get these and make changes to them. So that's why as far as our house state is concerned, we extend evolvable token type, and you can even start to see that here, where we have a couple of other methods around that to enable us to modify the pointer itself. This is the one other difference worth mentioning, that you're going to want to have a reference to actually get the pointer itself, and you'll use a linear pointer to modify your house state as time goes on and you need to make changes to it. And of course, we have a little bit of basic information about the house itself, such as the construction area, the number of bedrooms, etc. But all of that is essentially flavor text for the point that we're getting across here. So now that we've talked about that a little bit, the other thing that I mentioned earlier in passing while we were looking at that code example was the fungible token versus non-fungible token dichotomy. So fungible tokens are essentially things that can be split. So a currency is a good example of a fungible token. You can split a currency. I can take 50 cents, which is 2 quarters, and separate that into two 25-cent elements. I can't take a bathroom and split it into 2 half bathrooms. That tends to not be as useful. So you can split currencies and combine currencies. That is a fungible property, but a non-fungible item is something that cannot be split. You can't split a house and put it back together. Be aware of that. So both of them are types of abstract token, though. And that's the most important thing to just keep in mind. So I'll show you an example of a non-fungible token. At least as far as the code is concerned, it's not very complicated, so it will be pretty quick. This one's going to be inside of house token create and issue flow.java. So if we're going to deal with a fungible or non-fungible token, a lot of the things in a flow would look the same. Here we just have a flow that returns back a string. And so initializing our flow looks relatively similar. We have an owner, a currency valuation, number of bedrooms, etc. Remember, this is a flow that's initializing a house, like we were talking about earlier. So there's the number of bedrooms, the construction area, the valuation, additional info, and the address, etc. So when we run our flow, we grab the notary from the service hub. As usual, we get our identity, and we get a unique identifier to construct the output state. That's going to be the house. So we create a house state, and here we're just initializing our house state that we looked at earlier, like we would normally. There's nothing too crazy happening here, even though that is an evolvable token type. We don't actually do anything too different here. We create a transaction state, we run a subflow for creating evolvable tokens. Now, in this case, right, we're creating that new house token. The token SDK provides create evolvable tokens flow. That's what this is, which can be called to create an evolvable token in the ledger. And so that is going to be the first big difference you're going to want to keep in mind. Separately, as you create your actual house token itself, we'll create a non-fungible token called house token, and it just uses the non-fungible token builder. It uses the house state.toPointer method to get the token type. That's the method I was talking about earlier. This just gives back a linear pointer to the house state class. This linear pointer will give you what you need for the non-fungible token builder, issued by issuer, held by owner, and we just call that build non-fungible tokens method on it. So, that being said, that non-fungible token is really all we need to call this build non-fungible token method. If you are building a fungible token, you'll have a little bit of additional metadata you'll need to use here, but it looks largely the same. There's not a very big difference. So be aware that that's really all you need to do. You need to make sure that you call the correct subflow to create the kind of token you're creating, in this case, an evolvable token. And then you're going to need to make sure you use the appropriate builder for your token. All that being said, that's pretty much all you have to keep in mind from the code's perspective as far as what you need to do there. And again, this code is available online. Hopefully Peter can throw a link to it in the chat if I forget to do so. That being said, we'll jump back into the slides, and I'll tell you just a little bit of the subflows that you're going to want to keep in mind. So there's create, move, update, issue, and redeem, like we talked about earlier. And a lot of these are very intuitive. Create creates tokens. You can move them, move fungible tokens, move non-fungible tokens. That's relatively intuitive. Similar thing with update. You can update evolvable tokens. You can issue tokens. Then you can redeem. And just remember that redeeming a token destroys it. Redeeming a token says, I'm now going to take possession of the underlying asset or underlying object instead of the token itself. I'm going to go to the coat check and I'm going to give them my tag that says my coat's number on it. They're going to go grab the coat, and then the coat check tag itself is thrown out. And that's all that really needs to happen. So if all this sounds a little bit abstract and the coat check example maybe makes sense to you, but it's not super clear, I'll give you some potential use cases to think about when it comes to tokens that are either evolvable or fixed. So for some fungible token examples, keep in mind, let's say, an evolvable fungible token, which is a tokenized real estate property rental. Let's say you can get fractional ownership because it's fungible. You can separate it and rejoin it. So let's say I invested in buying a house with my cousin, and so the two of us have fractional ownership. We could use an evolvable fungible token to represent that relationship. Separately, if I'm looking at an evolvable non-fungible token, that could be real estate that I own myself. If I bought a house or a condo myself and I was the only person who could own it, I bought it myself when no other owners, no co-investors. So that could be a good example of a non-fungible, right? The house that cannot be split in that case. And that, again, just depends on how you model it in your code. As far as fixed type fungible tokens, there's things like digital dollars, right? And non-fungible would be something like a gold brick. You can't break a brick in half, right? Well, or at least you should not break a gold brick in half. And so that would be something that's fixed. It has a set weight. Let's say it's 1 troy ounce. That fixed type non-fungible gold brick is going to be something that only has one, that only really has one owner, and that you're not going to break apart or reattach or anything like that. You know, you can't weld the gold bar together. That would destroy its value significantly. That being said, as far as types, there's on-ledger and off-ledger assets. Now, again, a security issue on a Corda issued on a Corda network could be anything, and all that. The only requirement really is that you and the people you're transacting with on your Corda network, let's say Titan Technology Partners and Bayes Transcorp, they only need to agree using contract language and agreeing as far as how they'll interact in the outside world based on the Corda network. They only need to agree that they will both abide by the network and treat the network as the source of truth. At which point, if they have a security on the Corda network, then they're obligated to that security in real life. And of course, real world physical assets off ledger could be anything, such as a house in Manhattan. And that's pretty much it. So hopefully this is starting to really sink in. And if not, no worries. We are always here to take questions. You can definitely post them in the chat. As far as actually trying this for yourself, the sample I pulled out was the dollar to house token, or the CorDapp, but there's a bunch of examples inside of the tokens folder. There is samples Java and samples Kotlin. Feel free to look at either of them to find the source code to the examples I showed you today or any others. In addition, there is, of course, the Corda Token SDK source code. Corda and the SDKs, such as accounts and tokens, are all open source. So there's a couple CorDapps I would recommend taking a look at. The flows here are going to be very helpful. The Fungible House Token CorDapp serves as a basic example to create, issue, and move fungible tokens utilizing the Tokens SDK. Makes sense. The Stock Pay Dividend CorDapp aims to demonstrate the usage of the Token SDK representing stock. And in that example, you'll see that the stock state actually stores more details like dividend percentage that can be updated over time. And lastly, the Bike Market CorDapp, which demonstrates a lot of the actions we talked about just on bikes, which are a pretty tokenized asset. So if all of that makes sense and you're ready to build, then off to the races, I guess. We're happy to support you. We're here to help. And please do take a look at the training site, what's new, and if you need any help with specific problems you come up against when working on CorDapps. It could be anything from compiling your CorDapp to trying to send requests at a Spring Boot server that you set up to run flows. Anything like that, you can feel free to ping me or my colleagues on Slack. You can read the Corda documentation or take a look at the GitHub repository, and you can email us. The email is devrel@r3.com. You can take a look at our Twitter or on our YouTube channel. So without further ado, I'd like to thank you for watching. I hope you found this useful. Please do feel free to like this video if you're watching it on YouTube, or if you have the ability to, subscribe to our YouTube channel and click the notification bell. It really helps us out, and you can get informed about other useful content like this from not just me, but Anthony, Ashutosh, Arena, Jenny, and Peter. So thank you again for watching. I hope this was useful for you. And please do feel free to reach out. I'll take a quick look at the chat and see if there's anything else for me to do. Otherwise, I think we are all good. Yes, the presentation will definitely be available later. You can message me on Slack for that. All right.